Okay, so this is my demo set. Like I shown in the slides. This is the MFC this modular fuel cell instead of methanol fuel cell. This modular fuel cell is named this way because of Horizon. Because Horizon named this modular. Why modular? Because inside it's all controlled by different modules. For example, the reformer system where the electrochemical reaction happens, all the pumps and the valves, they are all called modules. That's why this is called modular fuel cells. Okay, this modular fuel cell, lead acid battery, methanol is provided, and a cabinet here is provided by the Horizon company. So we do not do this on our own. Okay, but however, these cameras on top here this power supply box is provided by SPF. So we also don't template with this. However, what we build is all the device here. You can see the circuit breakers, all the electronic wirings is done by us. So this is my role, which is the central control unit, which is called, can be the computer, to gather all the data and flash it on this GUI. So for especially the voltage and the current, you can see it's very similar to the voltage and current shown here. Output voltage, output current. However, there might be some disparities because the current sensor we use and the voltage divider, can see from the here at the corner there, might not be tuned in the right way to this MFC system. That's why you can see that some values can be different. Okay, so and there's the door opening indicator, which is used by this light. So for example, if I want to close this door, the GUI here will gone, no more. So it indicates that the door is open. See, it's open. So if I template with this Mario, you will see that the graph is have a fluctuation, which means that the thing is being tempered. So it shows that yes, there's someone is touching the things, or so you need to go down and look for it. So I will let Anissa to explain more on the voltage and the current. Singapore Police Force.
So the method is I think the voltage sensor is over here. So the voltage sensor, sorry. So the voltage sensors, like, we actually wanted to use a Hall effect, but then when we search online, the rating is too high for our system. So what I did is to actually solder two resistors, a 30k ohms and a 10k ohm in series, and then that's another solder lah. So for the Hall effect sensor, I just bought it online, which is rated at 10 amps. So both is actually connected to the Mario to get the data over here. But actually only our voltage sensors is connected to the NCB, and then it's connected back to the battery. And also we have the LCD to display the voltage, the current and the power. So when example you want to do maintenance and you switch on, you open the door and then the the data is already there. So you don't have to look at over here to see what's the power, the current or the voltage. So everything is already been displayed there. And on top of that, it's our CCTVs given by the SPF. So it's connected to the MCB. So anytime you can just switch on or switch off the MCB, or if you want to turn on the camera lah. So this is the software that is actually given by the SPF. So actually one of the part is actually not working, it's spoiled. So you're only able to connect 3 cameras. So this is the 3 cameras. It's actually connected by the Ethernet cable. Yeah. They have all of these. They have a unique IP address given by the SPF lah. So it's a lot of IP address, and you have to one by one add it inside your laptop, and then you're able to run the software.
So this one maximum can connect to how many cameras?
As much as you want, but then the software is only, they give only 4 cameras.
4 units?
Yeah.
And now maybe you can hear the buzzer. The buzzer also another indicator that shows that the door is open. Yeah, so people might Oh, okay, the door is open. Yes.
Yeah.
There's any questions?
So which part of the work is done by you?
What? Sorry?
Yeah, which part of, are you doing the wiring?
The wiring is we did together. It's just the my part is what I did is the Hall effect, the voltage, and a bit of the software.
Okay. How do you arrange the wiring, like MCB, where to put, how to put this?
Okay, so what I did is actually I did a schematic and a single line diagram lah. Yeah. So okay. So you only look at the single line diagram. So this is the MFC and the battery. So we label the MCB 1, 2, 3. We use up to 6 MCB. And then usually the battery is the one that's the most important thing. We put it all the way to the right hand side. The cabinet. And on top of that is just the second important thing is the MyRio. After MyRio will be all the sensors. Yeah.
So what is the current limit for this step?
Sorry?
What is the current limit? Your MCB, how many?
It's using a 10M MCB.
10M.
Yeah. But then for this diagram, like we actually loop the 12 volt. So we have a stable 12 volt MCB going through the system, 12 volt, stable 12 volt. So we just loop on top of it only. And then this is the output of the.
So you have 6 MCB.
Yeah.
And then each MCB have 2 connections.
Only for this one you have like separate connection. Only in this one is just single. So this one we have about connected to it 3 wires in one MCB.
All the sensors is given by SPF or
No, we buy.
We buy one.
SPF is only the camera.
Yes.
Yeah.
camera?
And then the horizon is given by,
Horizon is just
Horizon
biggie for
is just this one, this fuel cell generator, the lead acid battery, and the methanol.
the cabinet.
Yes, and the cabinet is from Horizon.
Yeah.
you bought it from Horizon or they
We
sell-
bought it from
Yeah.
Horizon, so it belongs to school now.
Yeah.
Yes.
How much current normally generate?
The energy is usually it's 100 watts and then it's 12 volts, so you need to do a
About
calculation.
8.3
Yeah.
8.3 amperes. 8.3 amperes.
Because I see now is about,
Cause is charging the battery itself. So there's one problem with this. Every time it charge the battery, the current is positive. Every time cause this system there is one fault, you need to boot up. So every time I switch on, you need to boot up for 48 minutes. So
How
during
many
this
minutes?
48 minutes.
48 minutes.
Yes, it means for him to warm up, to put up. So this 48 minutes, right, you will take the voltage and the power from the battery. So this voltage, this current sensor, there's a arrow, which I can show you. There's an arrow here. So if we do it wrongly, right, the current is negative value. So yes,
Negative value is just the reading, but it won't affect anything, right?
I know.
yes, it won't affect anything. Even on here, it shows negative because it's drawing current from the battery. Yes, so now it's charging the battery. That's why the current is positive. So this one might also affect our power calculations because what we wanted is when the MFC is charging the battery and not destroying the power from the battery. Yes.
So how long it can charge this battery to full load?
How long? It really depends on how much power the battery is being used. So, but normally if this one is fully drawn out, I think MFC cannot work one. So every time this battery left less than 20%, the MFC will detect that the voltage is low. So you need to change a new battery or you charge the battery manually outside. So this might be a further project we wanted to work on. Yes.
So you need to keep the battery at least half load before
At least 80%.
80%.
At least 80%.
Just wondering, do you need any feature to detect any abnormality like the current or the voltage?
No, not yet.
Not yet.
So this one is just to monitor.
For monitor
Yes,
only.
monitoring
Yeah.
An officer need to.
Yes, officers ultimately want to know how long this camera can last with this system. Without all the devices here, how long this one can last. their ideally is to last 40 days without topping up the fuel. But however, for our own current subject, our current project, with all these electronic devices connected, because there's power being consumed. So this one can only last 20 days. 20 days. So if we remove all this one can last longer.
So this one is supposed to be for portable usage.
Yes,
Yes.
portable usage. Yes,
Anywhere.
ultimately this one need to go
I mean, there's no
outdoors.
access to electricity,
No
No.
access.
the remote areas.
Yes, in remote areas.
What's the cost using fuel cell? Is it
This one is some surprise. I think it's quite expensive.
a future option, not
Yes,
today's
future options.
Still in development, the fuel cell.
Roughly how much it is?
Roughly the whole system roughly about 10k. I can say 10k SGD. About 10k.
Maybe I say something about the fuel cell. Now the most expensive component actually is the membrane, the reactor. So that one, because we are using for educational purpose, Horizon is very nice. Actually, we say $3,600 for the fuel cell.
The market price normally is
Oh, then I think it's about $7,000 US.
US.
Because this is just like the 30 years ago, the beginning of the solar panel. Now the price has dropped 90. This is 200%. At the beginning, this is very expensive, but now the solar panel actually everyone can afford to buy one. Yeah, so
So now you're the pioneer.